All right, 32. Triangle PQR has vertices -3, -1, -1, 7, and 3, 3. Points A and B are midpoints of line segment PQ and RQ. And then it says, using coordinate geometry, we want to prove that line segment AB is parallel to line segment PR and it's half the length of PR. So before we jump in, I just want to go over what's really important in the question here and how we're going to solve this. So as I look at the actual question, it says using coordinate geometry, we want to prove two different things. The first thing we want to show is that line segment AB is parallel to line segment PR. All right, that's the first thing. I know that if line segments are parallel, that means their slopes are equal. So I'm just going to write that down, equal slopes. So that's going to be my plan to show that those two lines are parallel. Next, it says, I don't only want to show that AB is parallel to PR, I also want to show that it's half the length of PR. So I'm just going to fill that in. I also want to show that line segment AB is half the length of PR. All right, so that's the second thing that I want to show. And the only way we've learned in order to find the length of any type of segment is by using Pythagorean theorem. So I'm just going to add that, Pythagorean theorem. All right, so now that I've gone over what I'm going to do to solve the question, I have to evaluate the information they gave me. So I know that I was given triangle PQR. I already graphed it. And they also told me that these points, A and B, are midpoints of these two segments, PQ and RQ. Now, I didn't plot A and B because right now I don't know where they are, but I can easily find them. So I know that point A is going to be halfway. It's a midpoint. Let me box this. It's a midpoint of PQ. A came first, PQ comes first. So I know A is the midpoint of PQ. So I'm going to use slope to help me find the midpoint. So I'm just going to write that down. The slope of PQ is going to be rise over run. So when you count it out, you rise 8 and then you run 2. All right, so I'm going to write that down, 8 over 2. But again, if I'm finding the midpoint, I don't want to rise 8 and run 2. I want to go half that distance. I'm going to divide by 2 to find the midpoint, halfway. So 8 divided by 2 is 4. And 2 divided by 2 is 1. So this is really the slope I want to use to find that midpoint. So I'm going to do it again. So I'm going to go up 4 now, 1, 2, 3, 4, and I'm going to run one time to the right. And now I found where point A would be located. B came second and RQ came second. So I'm going to use the same method for RQ. I'm going to find the slope of RQ first by using rise over run. So if I want to get from R to Q, it looks like I have to rise 1, 2, 3, 4, and then I have to run to the left 1, 2, 3, 4. So this slope is going to be 4 over -4 because I had to go to the left. And then again, if I'm finding the midpoint, well, the midpoint is halfway. I'm going to divide by 2. 4 divided by 2 is 2. -4 divided by 2 is -2. And then I'm going to go ahead and use that new slope. So from R to Q, I'm going to go up 2 and then to the left 2. And now I found my coordinates or my point for B. All right, good. So now that I know where points A and B are, because they're midpoints of these segments, now I can actually start the question. So if I want to show that AB, well, right now I don't have line segment AB. So I'm just going to grab a straight edge and form that right now. I'm going to connect A and B. So I want to show that line segment AB is parallel to PR, and here's PR at the bottom. So I'm just going to make a little room here for myself. So we already said we're going to show this by finding slope. So I want to find the slope of AB. I'm going to write that down. The slope of AB. Here's my line segment. And I also have to find the slope of PR. And you always want to make sure that you're labeling your work so it's super clear for whoever is grading it. Okay, and then again, I'm just going to use rise over run. So it looks like from A to B, I have to rise 2 and then run 3. So I'm going to fill that in. It's 2 over 3. Now I'm going to find the slope of PR and hope it's the same thing. So to get from P to R, I have to rise 1, 2, 3, 4, and then I have to run 6 to the right. So it was really 4 over 6. But don't forget, I can simplify that fraction and it becomes 2 over 3. which is exactly what I wanted. So I'm going to go ahead and just highlight that because I needed my slopes to be the same, and they are. So now I'm going to go ahead and start answering at least the first part of this question. Are these two lines parallel? They absolutely are. So I'm going to label that over here, step 1. Line segment AB is parallel to line segment PR. And I know they're parallel because parallel lines have equal slopes. And I know that those slopes are equal because I just found that information. All right, step 1 is done. Moving on to number 2. Number 2 says we want to show that line segment AB is also half the length of line segment PR. So I'm going to go ahead and just draw another little squiggle here because this is going to be another set of work. So if I want to show the length, I have to use Pythagorean theorem to do that. So I want to find the length of AB and I want to find the length of PR. So let's jump in and do that. I'm going to start with AB again, and I'm always labeling my work. So I'm going to find the length of AB, and I have to use Pythagorean theorem, which is a squared plus b squared equals c squared. All right. Right now, I don't see that right triangle that I need, so I'm just going to form it. So I'm just going to dash out and dash out to form that right triangle. And I know the right angle is here in the corner. Those lines are perpendicular, so I'm good. Okay, so I can see that my height is 2, and I can see that my length at the bottom is 3. All right, so 2 and 3 is what I'm going to plug in for my A and B. C is the hypotenuse. That's what I'm solving for. So I have 2 squared plus 3 squared equals c squared. All right, 2 squared is 4, 3 squared is 9. So when I add 4 and 9, I get 13. So again, 13 equals c squared. But I want to get rid of that exponent too. So instead of squaring, I'm going to square root, right, to get rid of it. And then again, I'm going to leave it as just the square root of 13. So that's what my c value is for the length of AB. All right, now I'm going to do it again for PR. So I'm going to write it down. I have to find the length of line segment PR. And again, I'm going to do that by using Pythagorean theorem, which is a squared plus b squared equals c squared. Again, I don't have that right triangle that I need for PR, so I'm just going to dash it out to form it. So I'm going to just boom, 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 boom. All right, I know that there's a right angle in the corner because, again, those lines are perpendicular. So if I count it out, I can see that the height is 4, and I can see that the length at the bottom is 6. All right, so again, I'm looking for the hypotenuse, which is that C value. So 4 and 6 are A and B. C is what I need. So again, I'm going to plug in 4 squared and 6 squared for A and B, and I'm solving for C squared. All right, 4 squared is 16. 6 squared is 36. When I add them together, I get 52. So 52 equals c squared. Again, I have to get rid of that exponent. So instead of squaring, I'm going to square root. So that gets rid of the 2. And again, I'm just left with the square root of 52 as my value for c, which is really the length of PR. Okay, these are not perfect squares, so I'm just going to leave them like that for now. All right, but I'm supposed to be showing that line segment AB is half of PR. So I need this number to be half of this guy. All right, so I'm just going to check that. So if I were to write down half of the square root of 52, it should be equaling the square root of 13. I could type that into my calculator, and I should be seeing that those numbers are the same. And if they're not, then I know I must have made a mistake. So I don't have a calculator at home with me, so I downloaded this Calculator X app. It's a free app. If you guys want to download it at home, definitely do that. I know that there's other, calculator websites and things out there, so this is just one of them. It's what I use. So I'm just going to type that in. So I'm going to do 1/2 of the square root of 52. All right, and I can see that it's the decimal 3.605 on and on. So now I'm going to check, well, what's the square root of 13? And I can see that they're exactly the same, and that's what I needed. It's saying, let me try to move this out of the way here, that half of the square root of 52 should be the same thing as the square root of 13, and I can see that they are. Those decimals definitely equal out. All right, so I'm basically done solving this question. I just have to write my answer in word form now. So I'm going to just put a little 2 here because this is answering part 2 of the question. So I want to show that these two lengths are not equal, but half. So I'm going to write that line segment AB is half the length of line segment PR. And I know it's going to be half because half of the square root of 52 is the square root of 13. I know that those values equaled and they were the same. All right, and that's how you would solve number 32. If we continue on and we look at number 33, I know that we had wrote omit, so you are not going to do 33, so I'm going to actually continue, and we are going to jump right into number 34. All right, let me just pull this down a little bit. All right, let's jump in. So as we look at number 34, it says Kira has a square poster that she is framing and placing on her wall. All right, so I'm just going to stop and I'm going to highlight what's important here just in the first sentence. So it's telling me right away that she has a square poster. There's a lot of things that I can mark when it comes to a square. So I'm just going to come back to that at the end. As I continue to read, it says the poster has a diagonal that's 58 centimeters long. It's already labeled for me. So this is an important number, but it's already there. So I'm going to keep reading. And it tells me that it fits exactly inside the frame. Okay. The width of the frame around the picture is 4 centimeters. Again, that's an important number, but it's already labeled for me. So I know that the width around the frame is 4 centimeters. So I know that this distance up and down is going to be that 4 centimeters. That means this distance up and down is also 4 centimeters. Right? This distance, there's 4 centimeters all the way around. So you can go ahead and label that if you want. Totally up to you. I would definitely add it on. All right, now if I jump to the bottom, it says determine and state the total area of the poster and frame. So that's my question here. I have to state the total area of the poster and the frame together. And then I have to round that answer to the nearest tenth of a square centimeter. All right, so there's a lot going on here. So square poster was an important vocab word. I have to find the total area. Area is an important vocab word, all right? So as I'm looking at this picture, if I want to find the total area of the poster and the frame, well, if I were to just highlight what that is, the poster and the frame together, it's really this entire shape that I'm trying to find the area of. So now I want to ask myself, well, what shape are the what shape are the poster and the frame making together? Is it a rectangle? Is it a square? You know, what's going on here? Well, they already told me that the poster is a square, and I know that a square has all sides that are equal. So I'm going to go ahead and mark those right now. And if I know that these distances from the poster to the frame are equal as well, that means that not only is the poster a square, but I also know that the frame is a square as well. So this distance is the same as this one, which is the same as this one, and the same as this one. All right. So if I want to find the area of this entire thing, I'm really finding the area of a square. All right. So I'm going to write that down on the side here. The area of a square is length times width. So that's really what I want to do. So I want to find the length. Let me grab a different color of this line segment and the length of this line segment. Okay, and then I'll be good to go. So right now I can't just jump in and determine what those distances are. It looks like I have to start with the poster inside because that's the only information I was given to start with. So if I know that this diagonal is 58, I'm seeing these two right triangles that it's forming inside. So I'm just going to pick one to start with. I know it's a right triangle because if it's a square, there's 90-degree angles everywhere. And I also know that a square, all the sides are equal. So I'm going to start off by putting an X on the base and an X on the height because I have to find out what those lengths are to start the question. If I want to find the length of a right triangle, or really the length of anything, there's only one method we've learned. You got it. It's Pythagorean theorem. So I'm going to write that down. A squared plus B squared equals C squared. I know that my A and B values are X. And I know that my C value is 58 because C is the hypotenuse and the hypotenuse is across from that right angle. All right, I'm going to plug all this in and start solving. So X squared plus X squared is 2. X squared. I had an X squared on the left, an X squared on the right, and when I put them together, I have 2 of them. All right, 58 squared, when you type it in the calculator, is 3,364. All right, I want to get x by itself, so I'm going to start by dividing 2. All right, so now I'm just left with x squared equals 1682. And then just like the last question, if I want to get rid of that exponent 2, instead of squaring, I want to square root. So now when I type that into my calculator, I get the decimal 41.012193 ... If you guys remember from when you were in school, which feels like forever ago, but when we were in school, we had taught you guys that if this is not the final answer, you cannot round. You are not rounding, you are using the entire decimal. Okay, so now I know that this length at the bottom is that 41.01 blah, blah, blah. And I know this length on the side is that 41.01 blah, blah, blah. So I'm gonna go ahead and add that to my picture. So I know this length is 41.012193 ... And I know that this length at the bottom is also 41.012193 ... Okay, but again, that's only for the poster, and I want the frame. So if you remember from the beginning of the question, I know that this length from the poster to the frame is 4 centimeters at the top, and the distance from the poster to the frame is 4 centimeters at the bottom. So now this entire distance is really 4 plus 41 point blah, 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 plus 4. All right. So the entire distance that I really want is actually 49.012193 ... Okay, and it's the same thing at the bottom. The entire distance that I really want is 49.012193 ... All right, and now I'm ready to plug in to my area of a square formula. So I know that area is length times width, but it turns out that the length and the width are the exact same. And again, you would be typing in the entire decimal. All right, when you multiply those together, you get 2402.195, ... But at this point, this will be my final answer, so I don't have to include every number after the decimal because I want to round to the nearest tenth. So I'm going to just underline that. There's 1 0 in the number 10. So I want to go one place after the decimal. So it's either going to round up to a 2 or it's going to stay a 1. It looks like I'm going to round up to a 2 because 9 is the neighbor. So we get 2402.2 centimeters squared because again, we were finding area and area is squared. All right.